Alright, so my name is Nicole Rangel, and I'm doing Project 1 for Dr. Osbe, wind tunnel simulation using Ansys Fluid. My frequency that I'm doing is 20 Hertz. So first, we're going to go to Fluid Flow. Perfect. We're going to go to Geometry. We're going to go to New Designer Model Geometry. Should pop up the window. Perfect. And then here we're going to click the Z-axis, and we're going to have a Y-X plane. 2D. Perfect. Now we're going to start sectioning the wind tunnel. So here we have settling chamber, contraction chamber, test section. Test section. And diffuser. Perfect. 4 lines. Great. And then we're going to dimension them accordingly to what the project said. In the project, it was in inches, and the units here are in meters. So I converted them, and the settling chamber was 0.381 meters. And then contraction chamber was 0.6096 meters. And the test section was 0.3048 meters. And the diffuser was 1.0668 meters. Perfect. So that comes into here, and then we're gonna center it with the midpoint of the origin of the plane. So here we're gonna draw a straight line through all the sections, and we're going to dimension it, or let's add a construction point right in the origin so we can use that as a reference. Perfect. And then we're going to add a constraint to this midpoint, to the midpoint of the length of the perfect midpoint of the origin. So this was right in half. And now we can start drawing the outline of our wind tunnel. So we're gonna draw a vertical line here, vertical line here. We're gonna draw 5 vertical lines, and in these vertical lines are also in inches in the project, but I converted them into meters. So here, the vertical lines are... Okay, so here we're gonna go to dimensions, vertical lines here that I'm putting in are going to be in meters. So for the settling chamber, it was 0.5588. That's going to be for the same here, 0.558. And then for the contraction chamber, or not the contraction chamber, the test section is going to be 0.28. Perfect. And this one also going to be the same. Oh, didn't mean to press that. Forgot to press this. 0.28. Perfect. Alright, so now that we have these vertical lines, we're going to add a constraint where we're gonna pick the line, and we're gonna pick the midpoint of these vertical lines, and so they're evenly spread. Perfect. We didn't dimension this one because the diffuser has an angle, so we'll adjust accordingly to the angle. Perfect. Alright, so then we can start drawing the outline. So this settling chamber, contraction chamber, testing section, diffuser. Same on the other side. Diffuser, test, contraction, settling. Perfect. So now we're gonna add another line here so we can dimension the angle, which was 3 degrees. Where is dimensions, angle? We're gonna do this. Perfect. A9 is going to be 3 degrees, and that already fixes this on the other side. So this is what our wind tunnel should look like. Let's delete some lines that we will not need. Don't need these, don't need these, don't need these. These are not these. Okay, perfect. Alright. Okay, so we're going to delete this line here, I believe. This line, this line, this line, this line. So now we have an open wind tunnel with no lines in between. So then after, we're going to go to concepts. We're going to go surfaces from sketch. We're going to click sketch. Perfect. We're going to click generate, and here we have the wind tunnel in a 2D form. Perfect. Now we're going to go back into the workbench. Let's just update it really quick just to be safe. Perfect. And now we're going to open mesh. Should take a little bit to upload. Perfect. And then from here, we're going to click the Z so we have the X and Y plane. We're going to go here to mesh, and we're going to go insert, method. We're going to select this and apply. We're going to do this as triangles. We're going to go to mesh, and we're going to go to element size. We're going to put 0.01 to avoid any errors in simulation. And then we're going to go click here. We're going to click generate. Perfect. Now we have our mesh completed. And then we're going to go to edges, and we're going to press Control and select the walls of the wind tunnel. Perfect. And we're going to press N, and we're going to save that as wind tunnel walls. Perfect. And then we can click this and save it as inlet. Press OK. And we're going to click this, press N, and this will be the outlet. Perfect. We can click just to double check what we clicked on. Wind tunnel walls, perfect. Inlet, perfect. Outlet is perfect. Great. So then after here, we'll go back to the workbench. We'll update the mesh. Update. Perfect. And then we'll open setup. Double precision, process solver 1, that's fine. Perfect. Now this should open up. Should take a little bit to load. Perfect. Okay. Now that's done. Okay. This is what our wind tunnel shape and outlook should look like. So then, okay, so let's go to models. Let's turn on the energy and let's select our flow. Here they have K omega. We're in the project, we're using laminar flow. So we're gonna press OK. And then we go off to boundary conditions. We're gonna press inlet, and this is where we're gonna use the velocity equation that was given in the project. Since I'm doing 20 hertz, my velocity in the test section was 4.6062. I used that to find the velocity in the settling chamber. I used V1 A1 equals V2 A2. And that I got the settling chamber velocity to be 1.25626. Perfect. And this was for 20 hertz. So then that's how you would find that. Let's apply again. All right, let's close. Outlet should be perfect. Pressure outlet. Wall should be wall tunnels. Perfect. So then we can go to initialization. We're gonna initialize. Perfect. Now that's done, we're gonna run calculation, and we can do 150 iterations, and we're gonna click calculate. So this is gonna run for a little bit. Perfect. Calculation complete. So now to get our images, we go to graphs, contours, not mesh, contours. Perfect. This is the pressure, static pressure, save, display. You would just take a screenshot and put this in the report of your project. Static pressure, drop down menu, dynamic pressure, save and display. Screenshot, put it in your report. Total pressure, save and display. Screenshot, put it in your report. Great. So for the graphs, we'll go down to plots, and we'll go to XY plots. So this is where you would get the data. This is where you would get your data. And then here we can go right and order points, so it comes out, the data comes out into an Excel file. And here we have pressure, velocity, everything else. Oh, I forgot to show velocity for the other one really quick. Contours, velocity would be here, display. Velocity goes, increases in the test section, highest in the text section, and it decreases as it goes out. Perfect. Okay, so we can end that. Back to the plots. Order to right, order points, pressure, static pressure, dynamic pressure. We're going to add a new surface. We're going to add a line and rake. This is going to be our center line. The dimensions are in meters, so I converted it into... The dimensions are in meters, and I calculated that to be 1.1831. This one is positive 1.1831. Perfect. We're going to create that and close. So then, after you have the center line, we're going to click center line, and this is going to be to the static pressure. And here you're going to write your file. It's going to be saved in the... This is where your file is going to be saved. You can label as static pressure on static P on center line. On center line. Something along those lines. And then you would do that for every term. Static pressure, dynamic pressure, right, same thing. Total pressure, right. Label your file, same thing. And then we're going to go to velocity, same process, center line, right, label the file as you wish, and then it'll save to your files. If you would like to just see the graphs on now without outputting a file, you can just unclick file, save and plot, and this is how it would look. And this is correct because as it goes, velocity increases as it reaches the test section, where the test section is right here in the middle. It's the highest in the test section, and then it lowers down in the diffuser. Velocity decreases as it exits out. And you could do the same as well for static pressure. High pressure goes down, 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 increases as it goes up. And then dynamic pressure should be the opposite of static pressure. That works out. Total pressure should be constant throughout, but the differences are so low that it's negligible, and it's constant throughout the whole simulation. That's how you complete project 1. Remember, capture all the graphs, import everything into Excel, create your own graphs, and that's it. All right, thanks.